This video is on systems of linear inequalities. I'm going to be doing the last three examples. This example 4 is we have y is less than negative 1/3 x plus 1. Since it's already in slope-intercept form, we can determine if it's dotted or solid. This is going to be a dotted line, so in blue I will be drawing a dotted line. For the next inequality, this is not in slope-intercept form yet, so we have to get the y by itself. When we get our y by itself, I will go ahead and put my y. I'm going to skip over the inequality for right now. But in order to get the y by itself, I have to divide by -3. So x divided by -3 is negative x divided by 3. Then the -6 divided by -3 is a positive 2. Now, as far as the inequality goes, if you divide or multiply by a negative, you flip the inequality. We divided by a -3, so the less than symbol needs to turn into a greater than symbol. This is also going to be a dotted line because this does not have a solid part to it. We're going to go ahead and put our x and y on our axes. We're going to put our count by. These can be counted by 1. So let's go and graph these. These are both easily graphable by hand without using the calculator. So for the blue, our y-intercept is 0, 1, so we're going to go to 0, 1. Then our slope is negative 1/3. So the negative goes on one of these. So we're going to put it on the top. So we're going to go down 1. Then that'll be a positive 3. So we're going to go right 3. So down 1, right 3. Down 1, right 3. Down 1, right 3. And then we're going to flip that to be the 1 will be positive and the 3 will be negative. So we're going to go up 1 and then left 3. Then we're going to dot this or dash it. So I'm going to connect the coordinates, but I'm going to be dashing them and then putting my arrows on the end. So for my pink, my first coordinate is 0, 2. So 0, 2. And then I actually have the same slope, so that's a negative 1x over 3. So down 1, right 3. These are actually going to be parallel. Down 1, right 3. And then up 1, left 3. Also dotted, so I'm going to dash those coordinates. And now we go to the shading. So for the shading for the blue, for the first one, the blue one, it says less than. So I go to my blue, anywhere on my blue, and less than means below, so I'm going to draw a line below. That tells me that I'm going to be graphing everything below this blue line. So I'm going to shade everything below this blue line. So for the pink, I'm going to go to the pink, anywhere on the pink, and it says greater than. Greater than means above, so I'm going to draw a line up. I'm going to graph or shade everything above, all the way along that pink line and above. So our solution is where the two colors overlap, and as you can see, the blue line, the first inequality, and the second inequality never actually overlap. Therefore, this actually means we have no solution. I'm going to put that on the side, no solution. And as before, this is a possibility because inequalities might not overlap. So this was a no solution because the lines do not overlap and the shading do not overlap. On example 5, these are already in slope-intercept form, so it'll be a little bit easier to graph. So on the first inequality, this is going to be a solid line because it is less than or equal to. And for the second one, this will also be a solid line because it's greater than or equal to. So for the first one, we want to go ahead and put our x and y axis on here and our count by. We can count by ones. our blue line, our first one, will have a y-intercept of 0, so 0, 0, and then our slope is -4/3, so down 4, right 3. Down 4, right 3. And then we're going to go up 4 and left 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Since it is solid, we can just connect all of these coordinates. We do not have to dash them, we just draw the line all the way through. We're not going to shade yet, we're going to go to the pink. That is y is greater than or equal to -x, so our y-intercept is also 0, 0. But then our slope is -1. So we're going to go down 1 and right 1. Down 1, right 1. Do as many of those as you can all the way through so you can get them as accurate as possible. Then we're also going to go up 1 and left 1. Keep going. This is also a solid line. Okay. These lines are pretty close together, so it's very important that you're careful on your shading. So let's shade our blue. The blue, so I'm going to go anywhere on the blue, and it says less than. So less than means go down in value, so I'm going to draw just a line down on the blue. So if I go along the blue, I'm going to shade on this side of the blue, all the way along the blue. Shade all the way along the blue. Don't worry about the pink right now, I was just focusing on the blue. So now on the pink, again, I'm going to put a pin on my pink, and it says greater than. Greater than means above in value, so I'm going to draw a line above that pink. So all along the pink, I'm going to be shading above that pink. So I'm going to go towards the pink, all the way on the pink, and shade above it. So now we got to find where the two colors intersect. Blue and pink are both in this little section here, so that's our solution. So I'm going to darken this up with my pencil a little bit, and then I'm going to highlight it. Now, since both of these are solid, what that means that any coordinate that's on the line in this section is also a solution to this system. So before, when we had dotted lines, the coordinates on the lines were not solutions. But now, since they're solid, if it's solid, then that coordinate is a solution. So that coordinate right there is a solution to this system. And any coordinate inside of that shaded is also a solution. On this last example, we need to go ahead and put our first one into slope-intercept form. So in order to do this, we know we want to put our y first. Now the y is on the other side, so actually if I just add it to the other side, it's already going to be the y, so that one's fine. I'm going to skip the inequality for right now. If I move the y to over here, I'm going to have to add the x to the right-hand side. So I'm going to have a positive x, and then I'm going to have that positive 4. Because when we added that y to the other side, it became just a y, so y was done. We didn't have to divide. Now, since we did not have to divide when we put that y over here, when we added it, we did not divide or multiply by a negative, so our inequality will actually stay the same. This will be a dotted line. And for the pink, this one will be, it is in slope-intercept form, this is going to be a solid line. Let's put our x and y axis. And our count by, we're going to count by ones, because these are all kind of small numbers. Okay, so for the blue, our y-intercept is 4, 1, 2, 3, 4. Our slope is 1, so up 1, right 1. Put as many coordinates as you can, down 1, left 1. We're going to dot this, so I'm going to connect every other coordinate. And then for the pink, our y-intercept is 0, -6. So 1, 2, 3, 4, 5, 6. And our slope is also 1. So these lines are parallel. That does not mean that there is no solution. If this was a system of equations, it would be a no solution. But because it's inequalities, inequalities have multiple solutions because of the shading. This is a solid line, so I'm just going to connect all these coordinates. So for inequalities, the solution is where the shading overlaps. That's what we got to look for. So if we look at the blue, it says less than. So I'm going to go to my blue, anywhere on my blue, and shade down. Shading down. So this tells me that everywhere on this, underneath this blue, everywhere underneath that blue is shaded in blue. So I'm ignoring the pink for right now, because I don't care about it yet. Once I get done with the blue, then I care about the pink. So I go to the pink, anywhere on the pink, and it says greater than. Greater than means above in value, so I'm going to be shading up. Now this tells us that with regard to this pink, everywhere above this pink, everywhere above this pink is shaded. So even with regard to that blue, it's okay. Now we just want to see where do the pink and the blue cross. And the pink and blue do cross in this middle section. So actually, this middle section is our solution. I'm going to darken this up a little bit. And then I'm going to highlight it. All of this is our solution. And it goes along forever as well. Now, any coordinate on the blue is not a solution, but any coordinate on the pink is a solution. So be careful about that, because we have one solid and one dotted. And also anything inside of the yellow, the highlighted, would be a solution. So again, this is solving systems of linear inequalities. You graph them and you shade them. I do want to show you this last example in the calculator to show you what it would look like if you were shading them in the calculator. So you still need to get your inequalities in slope-intercept form. So we put them in there in slope-intercept form. So I have x plus 4, and then my second one would be x minus 6. Now before I graph, I'm going to go over to the left and change the shading for both of them. Now the shading for less than is that little triangle that's pointing down and to the left. So not this one, but this one. So I'm going to go to the second one, and I want greater than. So I want the triangle that's pointing up and to the right, so this one. So now I'm going to press graph. Here's the blue. Here is the pink. And you see how the shading is crisscrossing in the middle, just like what we had here. So that is how you would see it in the calculator for the systems of inequalities. They will actually crisscross, because one is going vertically, the shading is going vertically, the other shading is going horizontally. So when they meet, they crisscross into little squares.